Alright, so today we'll look at section 7.3, which is on solving trig equations and maybe some inequalities if we get to them, graphically. Eventually, we're going to solve trig equations algebraically, okay, using a quadratic formula and stuff like that. But for today, we're going to solve graphically. The nice thing about doing it graphically is if you come across an equation you cannot solve with algebra, which some are extremely hard to solve, graphically will always work. So you can use graphical methods on anything. Algebraic methods only work when the equations are nice. Okay, stuff has to cancel, or they have to be nice problems. All right, so same thing I've said over and over. To find all the solutions to a trig equation, step one is to set your window on your calculator so you're looking at one period and find all the solutions in one period. Okay, I think we've done problems where we've had up to 2 solutions per period. Today we might do some problems that have 1, 2. I think we're even going to do one that has up to 6. 6 solutions in one period. So find all the solutions in one period. And then if they want you to take into account all the solutions, remember, you can't possibly list all the solutions. There's infinite. It's like asking you to write down every even number. You can't do that. So we find all the solutions, and then we put plus the period times k, or I think we've been using n in class. But it doesn't really matter what letter you use. K, I think the book uses K. And remember, n is an integer. Meaning you can add or subtract any integer multiple of the period to the answer you found, and you will find an answer in a later or earlier period. Okay. So that idea is the same. What's going to be a little different today is we're going to look at trig functions we haven't really looked at before. Okay, we've looked at like sine, we've looked at cosine, but something we haven't really done is looked at something like, instead of sine, let's do sine of x squared. Okay, so now what I'm really looking at is this. It's a trig function to a higher power. So if we look at what that looks like, it's a wave pattern, but in this case it doesn't dip below the x-axis. A little different than how sine looks. And then we can also take something like that and combine it with cosine. So now not only are we looking at a trig function with a higher power, we're taking one that's a higher power and combining it with something else. We can get a graph that looks like this. So there's a pattern to it, but when you start using higher powers and combining things, you don't necessarily get a nice symmetrical wave. It's periodic, but it's a little different shape. It's kind of like the profile of a molar or something. I don't know. It looks a little different. So what we have to talk about is, how do you find the period of a graph like that? It's clear it's repeating. I hope you can tell. But how often is it repeating? Every pi? Every 2 pi? Or is it even something else? All right, so any questions on how you would solve something like this? Anyone want me to go through that ASTC thing one more time? Maybe a little bit? Okay.
Can we just do it graphically?
Yeah, we can just do this one graphically.
Do you have to use the ASTC?
No, not on this one, because we're gonna focus on graphing.
Okay. Because the ASTC.
Okay. So to find the 2 answers, we just graph sine of x, graph 0.8. And the important thing is make sure you set your window to one period. What's the period of sine?
2 pi.
2 pi. So we're going to go 0 to 2 pi. As far as the highest and lowest, negative 1 to 1 is all you need. Negative 4 to 4 is fine. But you're going to see one cycle. You're going to see a horizontal line at 0.8. And then we just calculate each intercept. So I'll just hit enter a bunch of times and it'll pick one. So I get the one on the right. And now when I do the other one, I have to be a little bit more precise. I have to move my cursor closer to the one that I want. And it gives me the other one. Okay, so graphically, those are the two solutions. But did we answer the question? It said find all solutions. Did I find them all? Anything, Kelvin? No, how many did I find?
2.
I found the first two positive ones. But remember that wave is going to come back up in a second, and it's going to intersect again. So, Kelvin, do you remember what I have to do with each of those solutions to represent all solutions?
What was it?
How do we represent all solutions?
You put in the periodic, put plus
Yeah.
2 pi.
Plus 2 pi. N, right. We're going to put a variable in there, and that represents all solutions. So 0.93 plus 2 pi, and again, you can use K, you can use N. Just get used to seeing different letters. Maybe I'll switch it to K later on. It doesn't matter the letter. Okay. So what that means is if you took 0.93, and I'm just going to round it, if you add 2 pi, which is 6.28, 7.21 is the next solution you would see. Add another 2 pi, they're going to cross again at 13.49, 19.77. All of these are solutions for the wave crossing the horizontal line. And you can also subtract 2 pi. We could go to the left instead of the right to find more solutions. Okay. So any questions on that? All right, so just a reminder that if you set a trig function equal to 0 and you solve it, that's not finding an intercept. That's finding a 0. Okay, and we've done that before, okay, early on. Okay, so if you set a trig function equal to 0 and solve it, you are finding the roots, or the zeros of the equation. So, in the directions of a problem, if it says find the roots or find the zeros, what it means to do is set the equation equal to 0 and solve it. Tell me where it crosses the x-axis. So that last problem we just did, was it sine of x, was it 0.8? So if you wanted, you could do something like this. All I did was subtract 0.8, bring it to the other side. Now I have this equation equal to 0. Watch what happens if I graph this in y1. Okay. Watch what happens. So sine of x minus 0.8. Now I only have one graph, and it crosses the x-axis in 2 spots. Does anyone have a guess what those 2 numbers are going to be? They're the 2 numbers that we just found. So if I do second calculate 0, pick a point somewhere to the left. Pick a point to the right. Stop, 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 no, stop. Well, if you pick a point to the right and then you hit enter, the answer that you would have gotten is 2.21. Yeah, so, well, it cleared. Trust me, it would have worked. So it's a different way to solve the problem. So if you like doing an intersect, that's fine. If you like getting it all equal to 0 and calculating where it crosses the x-axis, you will get the same answers. Just be careful because your calculator might freak out. I'm not sure. All right. So when you have a more complicated trig problem, like this one, this has a cosine squared in it, and it has a sine in it. Those are the two periodic terms. What we have to do is figure out the period of that whole thing. Okay? And this is how you do it. First, find the period of each periodic term. Okay? What's a periodic term? In this case, that's a periodic term. That's a periodic term. 1 is not a periodic term. 1 is just a number. Trig functions are periodic terms. So find the period of each thing I circled. And then the period of the whole problem is the least common multiple of the individual periods. It's the LCM. So for example, let's say you had a periodic term and the period of it was pi. And you had another periodic term and the period of it was 2 pi. Can somebody just list off what are some multiples of pi? Yeah, we'll just go right in order. So we start with pi. What's the next multiple? 2 pi, 3 pi, 4 pi, 5 pi, 6 pi. Those are all multiples of pi. What are some multiples of 2 pi?
4, 6
Yeah.
pi.
2 pi, 4 pi, 6 pi, 8 pi. So if I asked you what is the least common multiple, what's the smallest number they both have in common? It's right there. 2 pi is the least common multiple of pi and 2 pi. So the least common multiple is a number that both things divide into without a remainder. Like if I said what's the least common multiple of 3 and 2, it would be 6. It's the smallest number that they both go into without remainder. And a lot of times the answer ends up being pi or 2 pi, most of the time. Okay. So what we're going to do, we're going to make a chart for how we can figure out the period of the individual periodic terms. Okay? We know how to do it if it's just sine or just cosine. But the problem is, what about when it's higher powers? Cosine squared. Okay. So here's a table that describes what to do. So basically, the period of a function depends on whether or not you raise it to an even power or an odd power. For any of the ones you see here, tangent and cotangent, it works all the time. It could be an even or an odd. It doesn't matter. But if it's sine to an even power, secant to an even power, cosine to an even, or cosecant to an even, that is the formula you use to find the period. Pi divided by b. Okay. And if you don't remember what b is from when we do transformations, b is the number in front of x. So I'll skip to the next problem actually I'll just double page so you can see it. I'm looking at cosine to an even power. Okay, cosine to an even power. Right? I'm using that formula. Now I have to look up what b is. What's the number in front of t in cosine squared?
2.
The number right in front of the t.
1.
Just a 1. Here's a problem where, I'm trying to show you one. Here's one where it's not a 1. Okay, in his problem it's a 2. Okay, so I have cosine to an even power, and b is 1. So you plug everything into that formula. Pi divided by 1. That's the period of cosine squared. Any questions why I used this formula? Because it's cosine to an even power. Any questions why b is 1? Okay. So now the next thing we have to do is get the period of sine. Now, normally it's going to be written like that. But if you don't see a power, it's always to the first power. Is first power, is that odd or even? The number 1? Is 1 even or odd? Odd. Okay, so sine to the first power, that's an odd. That's not covered by this formula. This formula covers sine to an even. If you have sine to an odd, or cosine to an odd, secant to an odd, or cosecant to an odd, you use the formula 2 pi over b. Okay, so certain conditions when you use pi over b, then sometimes you use 2 pi over b. Caitlin, looking at the sine term, what's the number in front of t? It's 1. So to find the period of sine t, we should already know this one, but if you didn't, sine to an odd power, use that formula, and then plug in 1 for b. So the period of sine is 2 pi divided by 1. It's just 2 pi. Okay, so now the period of that whole thing is the least common multiple of those two numbers, and we just did that. What's the LCM of pi and 2 pi? 2 pi. Now we've done the hard part. That's what you need to put on the end of your answer. Plus 2 pi k. What do you actually put for the first part of your answer? Use your calculator and see what it comes up to. Okay, so now we're going to graph it. I'm going to type in 2 cosine. I have to use x as my variable. Make sure you close the parenthesis. Plus sine of x. Plus 1. Now, how many equations did I just type in?
1.
I just typed in 1. So are we going to be using second calc intersect? No, intersect is when you have 2. What are we going to use? We're going to use second calc 0, and I should set my windows so that we're only seeing one section. But that's good to look at because you can definitely see it's repeating. Okay, but let's set it to 1 period. How do I know what 1 period is? We just figured that out. LCM was 2 pi. So now you're not going to see it repeating. You're just going to see one section. Bless you. Okay. And we're looking for where this graph equals 0. So second calc 0. Now, to me, it's a little hard to see right there. It looks like, does it come down and actually cross twice? Or does it just cross once? It does just cross once. If you zoom in there, you would see that. Okay, so pick a point to the left. Pick a point to the right. Okay, do your guess. And you get 4.71. So the answer is 4.71 plus 2 pi k. You're going to get that answer every single period, every single 6.28 units.
So when you plug it into the calculator, you put all of that to cosine squared t plus sine t plus 1 all in one thing?
All in one. Yep. If there was something on the other side and it wasn't equal to 0, maybe I would have put what's on the left in y1 and then what's on the right in y2. But since they already moved everything to one side for me, I'm going to plug it in the way they gave it to me. Any questions on it? All right, so let's try this one. So we have 3 cosine x minus tangent x. Okay. First thing I have to do is find the period of each term and then the LCM. What's the period of cosine x? Two pi. Right? If you're not sure, if you don't have it memorized, it's cosine to an odd power. Pretend there's a 1 there. And the number in front of x is also a 1. So look up your formula, plug in 1 for b, and you will get 2 pi. Okay, so that's the first one. How about tangent x? Pi. Again, look up your formula. It's tangent to an odd. That's pi over b is the calculation, and b is 1. So, same thing we had last time. What's the least common multiple of 2 pi and pi? 2 pi. So that means whatever answers you find in this problem, they are going to repeat every 2 pi units. Now I have to find the actual answers. Okay. How do I get the answers? What do I have to do? Karen? Yeah, so we're going to type it in. So we've got 3 cosine x not squared. So let's get rid of that. Minus tangent x. And no plus 1. Okay. Now before I graph it, what should I do? Change the window to make sure it's 1 period. If you did the last problem, this problem has the same period, so there's no need to change it. So I'm going to hit graph. And how many solutions does it look like I have? 2. Yep. So we get 2 solutions. Second, calc. Which option do I use? 0. So, point to the left, point to the right, hit enter. One of the solutions is 2.13. The other one is 1.01. Does anybody need me to find the other one? You just do second calc 0 again. Take each answer and make sure you tell me that they repeat every period. Any questions on that one? All right, so take a second on your own and see if you can figure out the period of sine cubed 2x, period of cosine x, and then find the least common multiple of those 2 numbers. Go ahead. Okay, so sine cubed 2x. Anyone think they got the period for sine cubed 2x. Mina?
Pi over 2.
All right, so let's take a look at our formula. We have sine to an odd power.
Oh.
So we're using the formula 2 pi divided by b.
Oh, never mind. I looked at the wrong thing. Okay.
So in our case, b is 2. What's 2 pi divided by 2? Pi. Okay, so we get pi, 2 pi divided by 2. Cosine, we should just memorize that one at this point. The period of cosine, just cosine by itself is 2 pi. What's the least common multiple of pi and 2 pi? It's 2 pi, we've seen that a lot. Okay, so that means whatever we get for an answer, or answers, we're going to put plus 2 pi k, or 2 pi n, whatever you want to put on the end. Okay, let's graph it and see what we got. Is this problem set up to do an intersect or finding a zero?
0.
It's definitely set up for finding a zero because it's equal to 0. The only time it's set up for an intersect is if you have something on the left and something on the right, and it's not a 0. Okay. So we've got 3 sine 2x cubed. Okay. Part of doing this is you have to know how to type it in. Okay. I will not help you the day of the test to figure out, what buttons do I press or how do I type it in. I'm showing you right now. That's how you type it in. Okay. Minus 2 cosine x. Okay. Always check your window, but it's the same period as the last 2 problems. Don't think every problem is going to be 2 pi. You might get a problem that's pi. Okay. It might be different. And we're looking for how many times it crosses the x-axis. Okay, so if we make that a little bigger, how many times does it look like it crosses?
6.
Yeah, there are 6.
Oh, yes.
So other than being a little time consuming, it's not any harder. You just have to calculate all 6 of those intersects. Probably more than I would give you on a test question. But I already calculated them just to save time. So all the intersects are at, let's see if I can bring the graph down. The first one is 0.5, and then 1.25, 1.57, 1.89, 2.65, and the last one is 4.71. And just to kind of save myself from having to write it, I just put plus 2 pi k for all of them, just like that. So, any questions on any part of that?
Can you write that as your answer on the test?
Yeah, that's okay. I'm not going to give you one that had 6. You might have one that had up to 3, maybe 4, but not 6. If you wanted to write it formally, somebody would expect you to put plus 2 pi k on each one. Any questions on that? Okay. All right. So when we're doing a problem with an inequality, it's pretty much exactly the same thing. You have to find the period, you have to graph it, you have to calculate the roots. But the only difference is, let's say I said to you, I don't want to know where this crosses 0, I want to know where it's greater than 0. Well, this graph is greater than 0 in that section, and it's a little hard to see, but that section. So there's 3 sections where it's greater than 0. You would just write down these intervals. That's all. And how do you do it? Find all the intersection points. So you still have to do everything the same, except you write your answer as an interval. Okay? Like from 0.5 to 1.6 or whatever it is. Just write it as an interval. Okay, so step 1 says basically do what you did before. Find all the solutions pretending like it was an equation. Don't do anything different. And then, once you get your answer, it is going to be an interval. So remember, intervals can have parentheses, they can have brackets. And you put a comma between the two numbers. Whether it's a bracket or parenthesis, it depends on the problem. If you can equal the number, like if it says greater than or equal to, use a bracket. If it says like it's strictly greater than or less than, use a parenthesis. So here's actually the same, I think it's the same one we just did. What I did in red again is I highlighted all the intervals that are greater than 0. So if we call these points, because I don't remember all the numbers off the top of my head, just call them A, B, C, D, E, F. Between A and B is greater than 0. Between C and D is greater than 0. And between E and F. Those are the 3 intervals that are greater than 0 in this problem. Any question on that? Intervals greater than 0. Okay. If the problem asks, well, where is it less than 0? Well, it's just the opposite. Between B and C is less than 0. Between D and E is less than 0, and so on. All right, let's try this one. I want to know where the sine is less than cotangent. Okay, where is the sine less than cotangent? Is this set up to do an intersect or to calculate a 0? This is set up for an intersect because you have something on each side of the problem and it's not a 0. Okay? So we're going to look for where these things cross and then specifically where is sine below cotangent. Okay. Let's start with the period. Okay. Hannah, what's the period of sine?
2 pi.
And the period of cotangent?
Pi.
Pi. And what's the least common multiple of that?
2 pi.
2 pi. So, actually I'm just going to skip to this step. So the period of sine is 2 pi. And the period of cotangent is pi. LCM, 2 pi. So what that means is once you get an interval for an answer, put plus 2 pi k on the interval. Okay. Okay. Let's graph it. So I've got sine of x. I've got cotangent, but how do I type cotangent in? Right, I got to do 1 over tangent. Okay, 0 to 2 pi, that's a perfect window because the LCM is 2 pi. Okay, so let's focus on what we're looking for. We're looking for where the blue graph is under the red graph. Okay, so let's mark the endpoints and let's mark the intersections. Let's call that point A, B, C, and D. Is there any questions on how you would find B or C? on the calculator? Okay, then I'm just going to call them B and C. Where is the blue graph below the red graph? Where is the first interval that happens? Between B. Well, what's happening between B and C on the red graph? We have to remember there's something there that the calculator didn't show. There's a vertical asymptote, so that's important. Because before that vertical asymptote, I would say the blue graph is above the red one. After that vertical asymptote, the blue graph is below. So you have to remember there's a vertical asymptote there. Let's call that point E, where the asymptote is. Okay. Between A and B, that's the first interval where the blue graph is below the red one. Okay. Any question on that? Between A and B? I mean, just look at it. The blue graph is under the red one. All right, so let's put our answers over here. All right, so from A to B, can I include A?
Yeah. Yeah.
Well, what's happening at A that I didn't draw it, but I drew one of them somewhere else?
Oh,
there's another asymptote here. There's another asymptote here. You cannot include a point if it's on an asymptote. Parenthesis.
I don't understand what you mean by under.
yeah.
Under? Well, if you look at the blue graph, it's underneath the red graph.
Like, you mean when it curves?
I'm getting
Mm-hmm.
Oh, okay.
The blue part is underneath the red part. Well, now you can't see it. But the blue graph is below the red graph. Look at the heights. The red graph is up higher than the blue one. Okay, so between A and B, on B, would I put a bracket or parenthesis? Well, I have to be strictly less than the cotangent. At B, they're exactly equal. So would I use a bracket or parenthesis? Parenthesis. If I put a bracket, then I'm answering this question. That's where they are equal. They don't want to know where they're equal. Okay. What about from B to E? Which graph is higher, blue or red? Blue. We don't want to know where blue is higher. We want to know where red is higher. So B to the vertical asymptote, that's not a solution. How about from the vertical asymptote to C? Which graph is higher? Red, that's what we want to know. Where is the cotangent graph bigger than sine? So from B to C, or I'm sorry, from E to C. Can I include E? It's on an asymptote, so no. Can I include C? No. It's not that C's on an asymptote, but the problem said where is it less than, not where are the graphs equal. So from E to C. And then how about from the last section, C to D? Which graph is higher? Blue or red? Blue. We didn't want to know where blue is higher. We wanted red higher. So that's the answer. So B should be very easy to find on the calculator. You just do an intersect. So should C. So should A, because that's the start of your window. That's 0. But E, how would you calculate a vertical asymptote? There is no button to calculate a vertical asymptote. But use common sense. Your window starts at 0. It ends at 2 pi. To me, that vertical asymptote looks like it's right in the middle of the screen. So where would E be? It would be at pi. It'll never be more complicated than that to figure out the asymptote. If you get that, then you should be able to fill in those letters with the correct numbers. Any question on that one? Yeah?
Where does the period come in?
The period comes in when you set your window.
Just the window?
Just Yep, and, oh, I'm sorry, and when you put plus 2 pi k, is that what you meant?
Yeah.
Yes.
When you write it out.
Yep, thank you for reminding me of that. So this behavior where it's above from here to here and, or actually below, sorry, below and below, those two things that I just traced in black are going to repeat every cycle. You're going to get 2 sections in every cycle that are below. So that's why you have to put plus 2 pi k. Okay, just like we did for the equations. Okay, questions on that one? Okay. Let's see. So let's finish up with a double inequality. So with a double inequality, the only thing you have to do extra is instead of just using y1 and y2, use y1, y2, and y3. Use all 3. And I want to solve that. I want to know where this graph is above or equal to negative x, but below or equal to positive x. So kind of what I'm looking for here is where is this graph in the middle sandwiched between 2 other things? Okay. So let's graph it. It doesn't matter which one you put where, so put negative x, x, sine x, and x. It's easier to do it in color because now what I'm looking for is where is the graph in red sandwiched between the blue and the black. That's what I'm looking for. Okay, and let's just do zoom 7. Okay, what I might want to do is zoom out a little so I can just see because it's going off the screen. So I just press zoom 3, it zooms it out. Here's your graph in red. There's your graph in blue, and there's your graph in black. So we are looking for where the graph in red is sandwiched between, let's see, the graph in red has to be above the graph in blue. So let's make this in color so we can kind of see it. Blue. So that's the graph in blue. That's the graph in black. Where is x sine x? That's the one in red. Where is the graph in red above the blue and below the black?
From 0 to infinity.
From 0 on. Right? From 0 on, the graph in red is above the blue and below the black. If you go before 0, it's reversed. That's not what we wanted. Right? So this is from 0 to infinity, which you could write that way as well. 0 to infinity. Why did I put a bracket? Because the problem said it was okay to equal. It didn't say, it has the equal to's in it. Okay. Any question on that? That's a double inequality. Okay. As far as, do you need to put plus 2 pi k or anything like that here? No. No. Because x is not a trig function. Negative x and positive x are not trig functions. So they are not periodic. Okay. Any questions on that? All right. And I think that's pretty good. Okay, so homework tonight, pretty much every question you do need a graphing calculator, so if you don't have one, you're not going to be able to do it. Okay. So homework's on 401. It's 5, 7, 12 to 15, that's all. But the rest is odds. 19 to 23. And I could just shorten this to say 29 through 37 odd. So we'll take a look at that tomorrow. And tomorrow will be the last day of new material for this week.